Okay, Precalc people, I'm making this video because you guys have 10 days off in a row, and I'm guessing that that's going to make it difficult for you to come back and then have a Precalc test if you haven't done any practice. So if you are watching this, you're smart. You're taking a minute out of your time to kind of refresh your mind with some of this Precalc. So let's say on the test we were to ask you to find the sine of 15 degrees. Well, there's no calculators allowed, otherwise you could just type it in. But since you do know these formulas, we're going to give you these formulas, and I've circled this one. That's the one you'd use here. And it's based on breaking this up into sine of two things that you do know. Like, you know how to find sine of 30 or the sine of 45. And that, of course, would, or not, yeah, sorry, sine of 30 and the sine of 45. And so these together, of course, don't make 15. These would make sine of 75. But if we need sine of 15, we need to find two things that you add together to make 15 or subtract. Well, you can't make a small number like 15 by going 5 plus 10 because we don't know what the sine of 5 or the sine of 10 are. We got to use numbers we're used to. So our bank of numbers we could choose from is we know what sine of 30 is. We know what sine of 45 is because, again, we can draw those triangles. We know what the sine of 60 is because we can draw a triangle for that. Those are the ones that are really commonly used. So then you can either add them together and make like 30 plus 45 makes 75, or subtract them. And in this case, I'm going to choose sine of 45 minus 30 to get my total of 15. All right, am I done? No, I've just got it set up. So now I can use this formula here and say, all right, that would be the sine of alpha, which in this case is 45, times cosine of beta, which in this case is 30. The two numbers are 45 and 30. And I'm just reading off this formula. Next it says plus over minus. Does it matter if it's minus over plus or plus over minus? Yes, it does. Since this sign is plus over minus, this is plus over minus, that means that I should use the same sign. So if I'm using a subtract here, then when I do the rest of the problem, I should use a subtract for this sign. Okay? Now it's cosine of alpha, which is the 45, and sine of the beta, which is 30. Am I done yet? Nope. Because now you've got to finish. Get my 2-minute teacher thing out of here. Hold on. Okay, I made some more room there. Now I've got to simplify each of these. What is sine of 45? Well, I can go off to the side, draw my 30, 60, 90 triangle, 1, 2, square root of 3, and my 45, 45, 90 triangle. That's 1, 1, square root of 2. And I'll get all my answers from those. Sine of 45 is sine is opposite over hypotenuse, so it's 1 over square root of 2, times cosine of 30. Well, I go to this triangle, and this is my 30-degree angle. Cosine is root 3 over 2, minus cosine of 45. I did that one. Cosine of 45, that's down in this triangle. Cosine is adjacent over hypotenuse, 1 over square root of 2, times the sine of 30. And hopefully you've memorized that one by now. It's 1/2. I also could do it from that triangle. And now, one of the things that works out really nice is these always end up with a common denominator automatically. So now I can put it all together. Root 3 minus 1 over 2 root 2. And there'd be your final answer if I had asked you for sine of 15. Okay? If you want to check and see if you know how to do this, you could try to figure out, for instance, sine of 75 degrees. And I'll give you a hint. Of course, you're going to make that into sine of something plus something. All right. Now let's move on to a different kind that you should be ready for. Let's talk about simplifying. If you are asked to simplify using sine, you should be able to give me several things you can replace sine with. So that if I said, what is sine of x? times secant of x. You can have a big list in your head of, okay, well, sine could be this or this or this. And in this case, sine is 1 over cosecant. All right? And secant is 1 over cosine. Now, did both of those substitutions help me? Not really. Not really, because this one and this one aren't like working out real nice. So I should probably only do one of those two substitutions when I'm simplifying here. Maybe if I just leave sine alone, you might notice that sine times 1 over cosine, if I can put this over 1, turns into sine over cosine. Is that a good thing? It is if you have memorized that sine over cosine is equal to tangent. All right, so you are expected to be able to pull up a lot of things. If they ever have a 1 minus, like cosine squared or sine squared, you have to say to yourself, okay, I know the ones that involve cosine squared. I could either replace that with 1 over sine squared, or you could just write down the identity that has a sine or a cosine squared in it. So in this case, the identity is sine squared plus cosine squared is equal to 1. And so now I can say to myself, how could I rearrange that to be the same as this? If I just move this cosine to the other side, then I have sine squared x is equal to 1 minus cosine squared x. All right, so now I can replace this whole thing with sine squared. Now, would they also have more to the problem? Of course. Unless it was an R2, well, even an R2 would be a little more complicated than this. They'd probably have something in there. Maybe on the denominator here, it might have been sine squared x. That way, when I replace the top with sine squared x, I'll have sine squared x over sine squared x, and those will simplify to equal 1. All right, what if they had said instead that they wanted you to prove that this was this whole thing right here? Let me clean it up a little bit. Bring this back. I'm going to go like this. I wanted you to prove that that was equal to sine squared x plus cosine squared x. Well, how does a prove work? On a prove, you have to leave one side or the other alone. And in this case, I'm going to leave sine squared x plus cosine squared x alone. And I'm going to simplify the left side. This can, I just showed you a moment ago, could be replaced with sine squared x. And on the bottom, I had sine squared x. So I leave the right side alone. I just put a double dash to mean I'm bringing it down. And this turns into 1 equals sine squared x plus cosine squared x. And again, I brought the right side down without changing it, because on a proof, you have to leave one side alone. But this is not good enough. Believe it or not, that's not good enough, because that is not a exactly equal statement. It's really close. Hopefully you know that you can replace a 1 with sine squared x plus cosine squared x. And then now it's equal to sine squared x plus cosine squared x. And that, my friends, is a proof. All right. You need to know a whole bunch of identities. I hope that if you saw something like this, sine of negative x, you'd be able to handle that one. I'll give you a second. See if you know that one. That one is negative sine of x. What if I had instead went with a go function and said something like cosine of pi over 2 minus theta? And could you replace that with something? Hope you remember those are the co-functions. And so like sine goes with cosine, secant goes with cosecant, tangent goes with cotangent. All right, well, cosine goes with sine. So this would be sine of theta. Because remember how this and this together have to add up to 90, or pi over 2 in this case? All right. Here's another kind of obscure kind of, what if I had asked you for what is tangent? You could replace that with, this is a quotient identity. Tangent is sine over cosine. I guess I used theta, so. If I had instead done cotangent of theta, could you do it? Cotangent of theta. Well, that's like tangent, which is sine over cosine, except it's flipped, because they're the flipping sisters. So it's cosine over sine. And then I gave you a few fun things to remember, like the 1 with the tan. Remember, these are always squared, is what we seek. And there's another neato saying. Do you remember the one with the coat? The one with the coat is cozy. And one more that we asked you to memorize is sine of 2 theta. So if you ever run across sine of 2 theta, you can replace it. This is not one of the ones we're going to give you, so you have to have it memorized. You can replace it with 2 sine theta cosine theta. So for example, in a problem, let's say I had given you sine theta cosine theta over sine 2 theta. It said simplify. Your first thought should be, oh, whenever I see sine 2 theta, you have to have this memorized. You're going to replace it with 2 sine theta cosine theta. And now do you see? Cosines will cancel, the sines will cancel. Hopefully you don't think that there's nothing on top. The top has 1, because when you're canceling these things, you're leaving behind 1s. So the answer for this one would have been just 1 over 2. It's an example of how to use that double angle identity. Well, I didn't intend to have you try to relearn everything here. I just wanted to give you a quick little review session to kind of tide you over between now and when we actually take the test. So you were wise to watch this, and I'll try to keep it short as I intended in the first place. I encourage you to go back and do any old worksheets that you've been given and double check them with the answers that are now posted. That'd be very wise. And when you come Monday, I'll give you one last review for the test that you'll have on Tuesday. Have a great day.